Welcome. In this video, we are going to continue our discussion on the regression analysis. Especially in this video, we will start with fitting nonlinear curves. So this is known as a curvilinear regression. Here also we have a bivariate data and we are asked to fit some best fit parabola. Here, if you see A, B and C are the parameters which are to be determined, isn't it? Okay. So how are we going to do it? The same way. What did we like? Let's go back and let me show you. So when we have a curve, what did we do? We defined some error term, and with the help of that error term, we were see here. What did we do? We defined error term to be yi minus a plus bxi, right? There we will have plus cxi square as well. And now that here in the case of curvilinear regression, we have three parameters. So we will have to differentiate that error term with respect to all the three parameters and equate them to 0. In that case, we will end up with three equations, and which are the normal equations. So with the given data, if we just calculate all these coefficients and substitute in it, and we'll end up with a system of three equations with three unknowns. Now it is just a matter of solving system of equations. Okay, when we had three parameters to be determined, we had three equations. So imagine if you have to fit a polynomial of degree p, in that case we will have to solve system of p equations. That's it, right? And here let us see an example. So we have a data and if you notice here, what are the things we need to find out? Summation y, summation x, summation x square, summation x cube, summation x power 4. There is a typo, it is c. Okay, it is not x, it is c. And summation xy, summation xy, x square y. All these quantities has to be calculated. Once we have calculated all these quantities, just substitute them in the normal equations and solve the system of equation, and you will end up with the values of a, b and c as such. And now that we'll just have to substitute these values into the general parabola equation, we get the best fit parabola for the given data. Okay. Next, we are going to see other type of nonlinear curves. We will start with an exponential curve. So here we are trying to fit the data into some curve of this form, that is y equals a e to the power bx. Here a and b are the parameters that are to be taken. Okay, that are to be determined. So for that purpose, what we are going to do is that we will take logarithm on both the sides. So we will take a logarithm to the base e. Okay, now in that case, what would it happen? It would be simply log y. Okay, this gets split into two things, log a plus bx. Okay, be it a or log a, it is a constant. Okay, bx, that is something seeming to be linear. And log y, if we take that log y to be some other y, yeah, because data values of x and y are known to us, that is given in the problem that we are going to deal, isn't it? So in that case, once you know y, you can very well calculate log y. Then things will flow as if we have done in the linear regression case. Here we have a problem. It is relating t and v. So in the place of x, we will have t. In the place of y, we will have v. Okay, so this is the required curve. When we take logarithm on both sides, this is what we would get. Okay, we are taking this log y to be y prime and log a to be a prime. Then we get y prime equals a prime plus bx, which is linear, isn't it? Linear. And now, so we let t to be equal to x and v to be equal to y. So this is what we have now. Okay, so from the given y value, we can very well calculate, that is from the given v value, we will calculate the log of those values, and that is what we have noted down here. Now the normal equations in terms of x and y prime would look like this. Once we calculate all the necessary informations and substitute here, we will end up with system of two equations. Once we get the value of a prime and b, substitute them here. Okay, and what is your y prime? It is log y, isn't it? When we take exponential to this term, that becomes y. Y is nothing but v here. So final expression in terms of v and t would look like this. So initially we were expecting to get something a e to the power bx, isn't it? So finally we obtained it. Okay, there we were expecting to fit a e to the power bx. Okay, here we are expecting to fit a x to the power b. Here also we are just going to take logarithm and make it as a linear equations. Once it is made as a linear equation, we can do with the linear regression technique. So here the problem states that the following pair of observations were noted in an experiment work on cosmic rays. We are asked to fit the data by the method of least squares for this equation. Okay, we have x and y. So when we take a logarithm, so it is a prime. Okay, some typos here, plus bx prime. So finally we let this a prime to be like this log a to be a prime, and log x to be x prime, and log y to be y prime. So finally, basically we have a linear expression in terms of y prime, a prime, b, and x prime. Okay, so normal equations in those variables would look like this. From the data, find x prime and y prime. That is, take the logarithm of these quantities and make another table. With that table, calculate all the necessary values. Once these are calculated, substitute them in the normal equations, solve for it. So you will end up with log y equals a prime plus b times of x prime, that is log x, right? So we had some expression of this form. Now that when you take exponential, this is how it will look like. Okay, and finally you have an expression of this form. Going further, next we have the concept of multiple regression. So till now what we were discussing was, when we had two variables, we will let y to depend on x. Okay, here here also we let y to be the depending variable, but it is depending on two things, x1 and x2. So we expect some relation of this form in the case of linear. Okay, so here we need a trivariate data. So once we have a trivariate data, of course we will fit it in this form. Then we define the error term, and when we differentiate that one with respect to the constants beta naught, beta 1 and beta 2, we will end up with some normal equations. We differentiate and let it equal to 0, and finally we end up with normal equations of this form. Okay, here we have a problem. So based on the experience and education, income in thousands are determined. Okay, so finally we are asked to estimate the income of a worker with 4 years and education level of 3. Okay, first of all, if we see, this needs summation x, summation x2, summation y, summation x1 square, x2 square, summation x1 x2, summation x1 y, and summation x2 y. So all this has to be calculated from the table. Once we have calculated, we shall substitute them in the normal equations. And now that it is a problem of solving system of three equations with three unknowns. Once we solve it, we get the values of beta naught, beta 1, and beta 2, and that gives us the expression. So in this expression, we are going to use to estimate the income of a worker with x1 equals 4 and x2 equals 3. Once we substitute it, we get something, and that is rupees 48,740 is the expected income of the worker. So the next idea is correlation, that we will see it in the next video.